So far in the past two lectures, we have discussed about sequential circuits. And if you go back to your digital circuit class, in the first introduction was on combinational logic circuits or logic gates. In combinational logic circuits, the basic purpose was to develop or generate an output at a particular instant whenever you change the input. That is, whenever the input is changed, the output changes instantaneously, and that output depends solely on the input present at that particular time instant. Next, we studied, or you already studied, something about called sequential circuits, that is flip-flops. Now, we have already seen that the sequential circuit is nothing but a combination of combinational logic circuit with a memory element. Now, what is the basic difference in functioning between this combinational logic circuit and sequential logic circuit? In sequential logic circuit, the output at any instant will be dependent on the input at that particular instant, but also on the output at the previous instant or any other state at the previous instant. To be precise, this should be kept in mind that for a sequential system, output at n plus 1th instant is a function of input at n plus 1th instant and previous output, that is output at nth instant. So it is not only dependent on the input at the present instant, but also will be a function of output at the previous instant. So that's why it's called a sequential circuit. Whereas the other one is combinational logic circuit, where the output depends solely on the combination of inputs that you are providing. Right. So now in this lecture, we will be combining the two ideas, that is the functional combinational functional blocks and sequential circuits. And then we will combine these ideas together and we will generate what is called a sequential functional block. These sequential functional blocks are generally referred as registers and counters. I guess you've already heard the name, the terms registers and counters.
Yes, sir.
So what is a register and what is a counter? How they are different? Any idea? Okay, I'll tell you. So far in sequential logic circuits, we have seen the flip-flops. We have studied the flip-flops, different types of flip-flops. And we all know that a particular flip-flop, a single flip-flop can store a single bit of data. But in normal operation, we require not a single bit of data, but an array of data. That's called a word. 4-bit, 8-bit, 16-bit, 32-bit, 64-bit, 128-bit. So that will require, for n bit data to be stored, we will require n number of flip-flops. When you consider this n number of flip-flops as a combination, we call them a register. Now registers, if you use the registers to only store data, then a flip-flop block with input and output and a clock will be sufficient. But whenever you are storing data, your purpose would also be to not only store the data, to perform some mathematical operation or some processing of the data. For that, what you need is a combinational logic circuit, so that the data stored in the flip-flop can be manipulated or acted upon, or it can be processed. So in a broader sense, the registers will consist of not only flip-flop but combinational logic circuits at its input side or its output side, so that it not only allows the data to be stored but also allows the data to be acted upon, that is the data to be processed, because data processing is also a very vital task of a register or in a digital system. So next operation will be, you know the registers are there, you know how to input data to the register and how to extract data from the register, and you know the processing that you require. For that, you have designed your combinational logic gates. The most important thing in the next stage will be to synchronize all these operations, that is to sequence the processing. So you have to first load the data, then process, then get it at the output port. So this sequencing of the processing is done by what is called counters. So basically, counters are a special form of registers, but still they're not regarded as registers, but they're regarded as counters. I'll come to it in a few minutes. Sorry. So what are the registers then? I've already mentioned that for an n-bit register, you require n number of flip-flops. Okay, so it is capable of storing n bits of binary information. So it will consist of a set of flip-flops together with gates. What are the purpose of the gate? The gates will implement the state transition. That is the data processing. How the data stored in the flip-flop will be changed or transferred, whatever. Right. So the flip-flops will hold data, and the gates, the combination of gates will determine how the new data will be incorporated or the present data will be transformed or transferred into other parts, maybe to other flip-flops. So this is a basic operation of a register. Whereas a counter is a register, obviously a special kind of register, I've already mentioned, which goes to a predetermined sequence of states. That is, the states of the counter are all predetermined. Sub counter, so it will come from 0, 1, 2, 3, like this. For down counter, it will count from 4, 3, 2, 1, 0. So this states or the sequence of states are predetermined, right? So how the states change? Obviously, the states will change upon the application of clock pulses. So obviously, the counters will consist of flip-flops along with gate circuits. Now, what will be the purpose of gate circuits? The gate circuits for counters are connected in such a way that it produces a prescribed sequence of binary states that will act as input to the counters, so that the counter output changes in a predetermined sequence, up counter or down counter. So it's nothing but a special type of register where the sequence of operation is predetermined, right? So this, that is a register and the counter will form the sequential functional block that is the integral part of any digital system in general, and especially it is the fundamental building block of digital computers, right? Where registers are used for storing data or manipulating the data, and counters are employed to sequence and control the operations in the digital systems. It is just synchronizing the every operation. So this is a basic difference between a counter and a register. Now let us start or discuss about the fundamental form of a register, most fundamental form of a register. See, I'll have to zoom out a bit. Just see. Is it entirely visible? Still visible? Can you follow?
Yes, sir. Yes, sir.
Okay. So what we have, okay, thank you. So what we have, 1, 2, 3, 4 D flip-flops. And they are connected to 4 inputs, D0, D1, D2, and D3. Now these flip-flops have obviously corresponding outputs, and they're excited by same clock. The clock is common to all of this. And there's obviously an option, clear bar, that is given so that the flip-flops, all the flip-flops can be reset. Clear means it will reset the value simultaneously for all the flip-flops. Now what is the operation or the functional operation? Suppose you have some data input at D1, D2, D3, D4, D0, D1, D2, D3. Whenever this clock, since this symbol indicates it's a positive edge triggered, this clock pulse goes from low to high, there's a positive edge appears, this data will instantaneously move over to the output, as well as it will be stored in this flip-flop, which can be read through its output. So basically, this operation is nothing but storing a 4-bit data into the flip-flop with the help of a single clock pulse. Then what is the purpose of this? Clear? Suppose at any sequence of operation, you need to reset all these flip-flops intermittently. So what you have to do, you just to put clear equal to 0. If you put clear equal to 0, then it will be 0 and reset will be high. So this reset equal to 1, if you can recall the preset and clear option or operation for a D flip-flop, that will reset the output of all these 4 flip-flops to 0. Then again, you can start your data entry operation from the very beginning. That is by incorporating new data in D0, D1, D2, D3. Now, one thing is to be noted here. Even if you change the data at D0, D1, D2, D3, it will not be loaded to the D flip-flops until or unless this positive or rising edge of the clock appears. So the data will only be transferred to the D flip-flops only when this rising edge of the clock appears. Suppose there are 2 rising edges. In between, whatever be the value of the input D0, D1, D2, D3, the stored data will remain same. It will not be affected. Now, if you look at the symbolic representation of a register, it is something like this. See, these are the 4 inputs D0, D1, D2, D3, and these are 4 outputs. Now, this sort of operation where all the data D0, D1, D2, D3 are entered in a single clock pulse is referred to as parallel loading. That is, all the data are loaded at a single clock pulse simultaneously. And again, all the data can be read from Q0, Q1, Q2, Q3 simultaneously. So that is also called parallel reading. Now, one thing is to be noted here that the nomenclature. This is clear, but this is clear bar. Sorry. Now, this nomenclature is used to indicate that to reset this flip-flop, internal to this flip-flop, the signal clear should be high. And since there is a inverter or a bubble, that means from outside, this signal should be low. So for normal operation of the flip-flop, this clear bar should be kept at 1 so that this remains 0. So the flip-flop operates, all the flip-flops will operate in normal condition. If you want to reset all the data, then only you put clear bar equal to 0. So this will become 1, and correspondingly all these values will be reset to 0. It has to be maintained that during a sequence of operations that is being carried out, you should not intermittently put clear equal to 0. Under such condition, all the flip-flops will be reset, and then will be malfunction of the flip-flop itself, because in the process of it's a process of data collection or data reading is going on. So only when you require a reset, then only this clear operation should be used. And you all know this is an asynchronous operation, right? It can be put on at any instant of time. So you should be very careful about these asynchronous operations because they are very detrimental to the system. Now coming to the register. Now we all know the data are now stored in the register. Now this data can be manipulated in the register in a way that we can shift the data within the register. Now how this shifting can be done? Suppose the data or the binary information can be shifted from left to right or from right to left. Accordingly, it will be called a shift left register or a shift right register according to the direction of shifting data. Now, whenever a data is moved into a register, that is loaded into a register, that is sometimes also called shifting of data. Now, there will be 2 ways of shifting a data into register. One is serial shifting, another is parallel shifting. Similarly, the output of the register can be read in a serial manner or in a parallel manner. Do you have any idea regarding this serial manner or parallel manner, serial shifting or serial loading and parallel loading? Anybody? Okay. So there can be 4 configurations, right? Serial in, serial out. See, this is an n-bit register. Suppose n equal to 4. So what do we have? We have D4, D3, D2, D1. But there is only one data input, single data input. And there's only one data output. So single line. So what you have to do, suppose you want to put a data 1101 to this flip-flop. Or this one, then this one, then this one, then this one. And this should be shifted in this direction. So at the end of the day, it will be 1101. So how many clock pulses will be required? It will require 4 clock pulses. At the first clock pulse, this one will appear here. In the next clock pulse, this will appear here. In the next clock pulse, that will move to this. And then on the fourth clock pulse, this one will move over to here. Consequently, this 0, after at the end of 4 clock pulses, will move on here. This one that is applied at third clock pulse will appear here. This one will appear here. So it will require 4 clock pulses or 4 rising edges, suppose, to load the data in a flip-flop or in a register or in 4 flip-flops which are connected in cascade combination. Similarly, to get the data from this flip-flop or to read the data from this flip-flop, you will require 4 clock pulses. So first, this 1 will be read, then this 0 will be read, then this 1 will be read, then this 1 will be read. So it will require 4 clock pulses to complete the reading operation. So this is an operation where you require at least 2n number of clock pulses to completely store the data in the register and to read the data from the register. So obviously you might say this is quite a slow register to load or to read. Next, we shall consider a situation where the data is being put in a serial manner, that is through a single line. Say for n bit, say 4-bit data, so it will take 4 clock pulses to put the data into the 4-bit register. Then the data output or the data can be read from the registers at simultaneous, that is at a single clock pulse. All of the data can be read at a single clock pulse. So that is called serial in, parallel out. So all the data are available at the output at a single clock pulse. So it will require only 5 clock pulses to store, 4 to store the data and a single clock pulse to read the data. Similarly, the third case will be parallel in, serial out. That is, all the 4 data for a 4-bit register will be loaded to the register at a single instant. Serial out is equivalent to serial in, parallel out. In a sense, it requires 5 clock pulses to complete an operation of loading and reading. But however, these are all faster than serial in, serial out because it requires 8 clock pulses, right, to complete the operation. Last but not the least will be parallel in, parallel out. That is, all the 4 data bits, say n equal to 4, will be loaded at single clock pulse, and that can be read or will be available in output, and that will require at most 1 clock pulse more. So this will be the fastest operation of loading a register and reading from a register, right? Can you find an analogy of this in your daily commute? See, this serial input, serial output option can be thought of as if you are moving in a metro rail, having a smart card. So we have to stand in a queue because suppose only one gate is open. So when only one gate is open, you have to move in a queue, put your smart card or token on the gate, and then you can enter. Again, when you're coming out of the station, you have to just put yourself in a queue, then put your smart card over the gate, and then it will open and you'll get out. So it's a serial input, serial output operation that you normally follow. So when you obtain the serial input, parallel output, suppose at a point of rush, there's a huge rush coming out at the station at say Esplanade. So when you boarded from Taliganj, you boarded using that punch or that token or your smart card in a serial manner. But when reaching on Esplanade, there was huge rush. So they say you just put on your token on your top of your head and just show the token and you can move on. There is no gate. A particular collapsible gate is open and you can move out simultaneously. So 5, 10 people can get out simultaneously. So that's serial in and parallel out operation. The reverse operation will again happen if there is a rush at the in and there is no rush at the out of a station. And if you find rush at both in and out, then there will be parallel in, parallel out. So these things Obviously, you can see that serial in, serial out is the most slow operation in terms of number of clock pulses required, whereas parallel in, parallel out is the fastest operation. So you might think, then why should you go for serial in, serial out operation? Thing is that in some situations, storing a data and reading that data is not sufficient. We need to do some operation or some, say, manipulation of data. Now, one of the basic manipulation will be to shift the data, that is from left to right or right to left. For that operation, that register can be used. But for parallel loading and parallel reading, that operation is not there. It can only load the data and you can read the data. So in a serial input, serial output combination, you can load the data in a sequence and you can output the data in a particular sequence, which will be beneficial because you may have a single input at the output of a register. So you have to have a serial data connection. This is a very specific case. Now let us consider one by one an example. That is serial in, serial out register. So let us consider first shift right register. Okay, in this PDF, there is one mistake over here. So when you are moving from left to right, it should be shift right. And when from right to left, it should be shift left. Okay. So you should be smart enough to correct this by yourself, I guess. So next consider a right shift. Shift right register consisting of 4 flip-flops, 4 D flip-flops. This can again be obtained using 4 JK flip-flops. Now for D flip-flop, we know to store a data 0 input 1 at instant. At that instant, the input should be 0. This clock pulse, this 0 will be shifted to this. Now in this configuration, see, the input, the serial input is connected to flip-flop A. The output of flip-flop A is input to flip-flop B. Similarly, output of B is input to C and output of C is input to D. But only input is given to flip-flop A and output is taken from QD. The clock is common to all the flip-flops. So all the flip-flops will react simultaneously to a clock pulse. Now suppose you want to incorporate a particular word into this flip-flop. Say that word is 1, 0, 1, 1. So at the input port, suppose at initial condition, they're all reset. Right? Now, to read this, to load this data, the final output should be 1, 0, this should be 1, this should be 0, this should be 1, this should be 1. This is a desired output. Now, the first instant to load this data, what you have to do, you have to start from the rightmost bit. So this comes over here. Now, as soon as the clock pulse appears or rising edge appears, this one will be shifted to this input to B, flip-flop B is 0. So at the first clock pulse, it will say this is the first clock pulse, green one. So this will move over to here, so it will be 0. Now at the next flip-flop, this input at same clock pulse will move over here. This 0 will move over here. So what is the binary data stored now? 1, 0, 0, 0. Now let us consider next clock pulse has appeared. And before that, we have changed the input or kept the input at value 1. So it's kept still at 1. And the second clock pulse has appeared. So what is the input to A? It's 1. So what will be its value? It will be 1. Now what about the input to B? This is the input to B when the clock pulse appears. So what is the value of the output? This one will be shifted over here. I should not draw over here. Now this was 0 after the clock pulse. So this 0 will shift over here. And this 0 will shift over here. So it is a new word 1, 1, 0, 0. Next, let us consider third clock pulse. red one. So now the input is changed to 0. And after that, the third clock pulse has appeared. So what will happen? This 0 will appear here. What is the input to clock B? The flip flop B. When this third clock pulse appears, it was 1. So this will get shifted over here. What is the input to flip flop C? When red, the third clock red appears, it was 1. So this one will get shifted over here. What is the input to flip flop D? When this third clock pulse appears, it was 0. So this 0 will get shifted over here. So what is the word now? 0, 1, 1, 0. Now, what is left with? The final clock. And the input now should change to 1. So the input is changed to 1 again. And the fourth clock has appeared. So what will happen? This one will move over here. What is the prior input to this? 0. So this 0 will move over here. The input to C was 1. So this 1 will move over here. Output of C. And this input to D was 1. So this D will move over here. So output is the final binary word stored in A, B, C, D, 1, 0, 1, 1. That is the desired word that we started with. Now to read the data, it will require again 4 clock pulses. At the first clock pulse, this will appear. In the next clock pulse, this will appear. Then this will appear at the D, and then this will appear at the D. So you will be getting the data in a sequence from right to left at the output. So have you understood this thing? How this operation takes place?
Yes, sir.
Okay. So this is very crude way of describing this. I have taken this graphical method, but there is another way of presenting this operation, that is by this table. See, the initial value was 0, 0, 0, 0. At the instant of first clock pulse, an input is now given 1. So at the first clock pulse, this 1 will move over to QA. This 0 will move over to this. This 0 will move over to this. As a shift operation is taking place, right? So then at the next clock pulse, again 1 is given. So this 1 will move over here. This 0 will move over here. So there will be a right shift operation taking place throughout the 4 flip-flops or an array of flip-flops, right? This is how a right shift operation can be carried out using D flip-flops. The same can be carried out using JK flip-flops. For that, what you need to know is that to incorporate or to input a value 0 over here, what will be your word? 0, 1. To incorporate a value 1 over here, it should be 1, 0. So whatever you put at J input, that should be inverted and put to the K input. And if you follow this rule, to input 0 or to make it reset, the word should be 0, 1. And to make it set, the word should be 1, 0 in terms of JK. So if you follow this sequence, then you can simply put the data 1, 0, 1, 1 into this right shift register. For that, I'm not going to describe this using this figure or this table. What we'll do, we shall discuss this using this timing diagram. Okay. So these are the 4 clock pulses. 1, 2, 3, 4. Now we have to store first a value. This is a word. So we have to first incorporate this value. So A flip-flop must be stored with 1. So your word should be J equal to 1, K equal to 0 should be the input. See, the input was there, prevailing, but output was QA was 0. It changes only after this clock pulse appears. And it changes to 1. But what is the input to flip-flop B? At this point is the output of A, that is 0. So it will remain at 0. Similarly, output of B is 0. So QC will remain at 0. Output of C is 0. QD will remain at 0.
Sir.
Next clock pulse.
Sir.
বলো
স্যার আরেকবার এটা ফার্স্ট থেকে
বলো
এটা আরেকবার ফার্স্ট থেকে স্টার্ট করবেন আর
আগে বলবো আচ্ছা ঠিক আছে Suppose we want to incorporate the same data 1, 0, 1, 1 using that 4-bit register. So we should start with this one. So this one should be first loaded to flip-flop A, and that is operation will take place on this first clock pulse. So prior to the clock appears, the input to the A, that is J and K, because input is only given to flip-flop A, was J equal to 1, K equal to 0. But the output of A was 0 because it was not recognized by the flip-flop. Now as soon as this clock appears, it recognizes the condition J equal to 1, K equal to 0, and it changes the state from 0 to 1. Right? What about flip-flop B? The input to the flip-flop B at this instant of time is 0. So output will remain 0. Okay? Because if you see the configuration, I think you have forgotten the configuration. See, J is connected to Q and K is connected to Q bar. Right? So whatever be the value of output of a one flip-flop will be the input to the next flip-flop in a J input, right? And the complement of output will be the input to the next flip-flop in K input. So in this regard, now there is one doubt that you might have, because you might say, I will expand this thing, that at this instant of time, at this clock pulse, the QA value has changed from 0 to 1, right? But QB value still remains 0. Why so? Because if you look closely, this transition from 0 to 1 isn't instantaneous. It reads the value at this point where the clock appears or the rising edge appears, but it takes a slight amount of time, that is delta t, which is the propagation delay of the flip-flop, and only after that delta t times QA changes its state from 0 to 1. So at that particular instant when that rising edge has appeared, what is the value of QA? At that particular instant is 0, and that is nothing but the input to QB. So at that point of time, because all the clocks are connected to the flip-flop, so say all the 4 flip-flops are excited by the same clock or the same rising edge. So at that particular instant, the input to B flip-flop is still 0. So the output of B flip-flop will remain 0. Although the output of A changes to 1, because that change occurs only after a period of delta t. Right? If that propagation delay was not there, then it could have been much complicated, because everything would be changing simultaneously, so there will be chaos. So in a sense, this propagation delay is a blessing in disguise. Understood? দেখো, এরে কেউ কিছু বোঝুনি নাকি? সবাই চুপ? হ্যাঁ না কিছু তো বলো।
স্যার এই প্রপাগেশন ডিলের জায়গাটা আরেকবার একটু বলুন।
হ্যাঁ, ধরো the clock rising edge of the clock has appeared at this point, but the state of the QA will not change instantaneously. It will change only after a period of delta t seconds. Say there is a propagation delay of flip-flop because it consists of memory element. Whenever there is a memory, there will be a propagation delay, and it consists of gates and other flip-flops, other components. NAND gates are there, or NOR gates are there, and there's a latch, things like this. So that will constitute a propagation delay. So this will take a delta t time to react to this clock pulse. In between this time, what about the input to QB? There is the output, input to the B flip-flop. There is the output of A flip-flop, that is QA. So at that particular instant, QA doesn't change. So it still remains 0. So the B output will be based on that particular value of 0, because at that particular instant, the input to B flip-flop is 0. If the propagation delay was not there, if A was changing at this particular instant, then for B flip-flop, prior to the operation of this clock pulse, it was 0. Now at the instant of clock pulse, it instantaneously changes to 1. So it might take 0 or it might take 1 as its input. So it might give rise to a 0 output or a 1 output. There will be no certainty about which value it will take. But if there is this propagation delay, then obviously this 0 will not change instantaneously. It will change only after delta t time. So it will definitely take this 0 value. Right. And that is what we desire. Because we know what our objective. Our objective is to propagate the data from one flip-flop to other at consecutive clock pulses. At n clock pulse, A will be updated. At n plus 1th, that A data will be updated to shifted to B. At n plus 2th instant, that particular data will be shifted to from B to C, and n plus 3 from C to D. And at the same time, from A, data will be constantly read, and that will be updated to B, and from B to C. So at each clock pulse, this operation of shifting data will happen in synchronism, right? If that particular propagation delay was not there, then it could have been anything. It may be 0, 1. The sequence will be completely broken. It will be like asynchronous or a very irregular system. That's why this propagation delay will be helpful. Although the delay term, we normally associate delay term with drawbacks. But in this case, this drawback is in a sense a blessing in disguise. Well, hello. Swarnadeep?
Yes, sir.
Okay. Another thing is you have to note that, see, the J input has changed at this point from 1 to 0. K has changed from 0 to 1. But the output of A flip-flop or B flip-flop has not changed. Why? Because the change appears only at the event of a rising edge of the clock. Whenever this event appears, then it reads what is the data J and what is the data K. And according to that, it will then update the state of the particular flip-flop. So this you should keep in mind. And this transition of state from 1 to 0 will not happen instantaneously. It will be preceded by a small delay of delta t. So that at this instant of time, the input to B flip-flop is still 1. It will read this value only. So it will remain at 1 value. Although the A output has come to 0. But it has come to 0 after a delay of delta t. So this way, you can easily describe the operation of a right shift register. Okay. So next, move on to the next register. What will be shift left? These are all written in a very lucid manner, so you can easily go through them and understand. And I'll recommend you to practice yourself. Okay. The next will be the shift left operation. See, the same thing, but thing is that now the input is connected to the rightmost, and the output is taken from the leftmost flip-flop. And the sequence is A, B, C, D. So your word will be D, C, B, A. In the previous case, your word was A, B, C, D. Since you're going for shift left operation, so first data will be entered here. Then in the next clock pulse, it will move over here. In the next clock pulse, it will move over here. And finally, it will move over here to the D flip-flop. So if you want to load, suppose a data 1110, 1110. So what should be the input sequence? Input sequence should be 1, this one, followed by 1, this one, followed by 1, this one, and 0. So it will require 4 clock pulses to move this one from the input data side to D flip-flop. It will take 4 steps, 3 more steps to move this data from input side to C flip-flop, because it is applied at say nth instant. So it is applied at n plus 1th instant. Now this input is applied as n plus 2th instant. So it will take only 2 steps to move from input side to B. And this will applied at n plus 3 instant. It will take only 1 step to move from input side to A. So the final word will be 1, 1, 1, 0. So it's a shift left operation. Understood? It can be easily understood just following the same analogy that we have discussed so far. বুঝতে পারলে তো? তাহলে ওয়ার্ডটা উল্টে গেল, তুমি এমএসবি থেকে শুরু না করে এলএসবি থেকে শুরু করবে, যখন রাইট শিফট আর লেফট শিফটের ক্ষেত্রে এমএসবি থেকে শুরু করবে। জাস্ট এটা এখন দেখার আছে, ঠিক আছে? এগিয়ে যাচ্ছি। So the table for this can again be done using JK flip-flops, and the table for this is this shift left operation. I've also given some example of practical registers, 8-bit serial in, serial out registers. This is for your knowledge only, so you can just go through them. Okay, these are practical registers. Now let us get to the hybrid condition where we have serial in and parallel out. Right? Serial in means the data will be incorporated in the register in a serial manner, but the data should be available at any instance simultaneously. And that will be nothing if we cut back to the previous figure. So this figure. So serial in parallel out means same thing, says left shift operation. So we have 4 outputs available like this: A, B, C, D. So as soon as these are loaded with your desired value, or it is 1011, sorry. So it is, since it is loaded with 1110, as soon as all the data are loaded in forced clock pulses, then in the next clock pulse you can read the data because the data is ready, and this all 4-bit data will be read simultaneously, and this is called serial in parallel out. The same thing will be applicable for shift right operation. There is, once the data is stored in a register, you can read the data simultaneously. Okay, so this is very fundamental, nothing new is to be learned from this, so I'll skip this serial in parallel out operation. Okay, serial in parallel out register. So it may be again shift right or shift left register as usual. I've given an example. Now the most interesting would be the condition where there is a parallel in but serial out. That is, all the data will be stored in the register at 1 clock pulse, that is simultaneously, but the register will be read in a serial manner, that is 1 bit at a time. So let us see how this configuration can be figured out. So this is the configuration. I'll try to zoom in. Oh, if I try to zoom in, I guess you can clearly see. Okay, what is the configuration here? We have 4 registers. Sorry, 4-bit register A, B, C, D. This is the 4 D flip-flops that are used, and this is the input to A flip-flop. This is the input to B flip-flop, input to C flip-flop, input to D flip-flop. Since it has a provision of loading the 4-bit data simultaneously in a parallel mode, all the 4 input channels are present. Then what are these gates doing over here? Because there will be 2 operations: one, entering the data or loading the flip-flop, that is by parallel operation, and next will be to get the data out of this single line. This is QD. This is only the output channel. So your sequence of output will be QD followed by QC. We have started very bad manner. So your sequence of output will be first QD will be read, then QC, then QB, then QA. So the shifting should be in this direction, from left to right, or is a right shift operation. To enable this, both the operations, that is parallel loading and right shift operation, we have a control signal over here. This is your control signal. What is the purpose of the control signal? See, it is written shift. So if you put shift equal to 0, then what happens? Say here it is 0. So following this, this will be 0. I think might be confused. This is 0, this is 1. So following this path, this input is 0. following this path, this input is 0 and this input is 0, right? So since this is an AND gate, whatever be the value at these three terminals, the output of this AND gate will be identically equal to 0. Or you can say this 3 will be producing 0 output. That is, they are taken out. What about the other 3? Since this is 1, so this will be 1, this will be 1, this will be 1. Or rather, I shouldn't write this. This line, this would be 1. So this line, this would be 1. This line, this would be 1. So whatever be the value at B, C, D, that will be passing through this gate, this line. And this is a simple OR gate. So that particular data will appear at input of D flip, this D, C, and B. And A output is already there. So as soon as this shift equal to 0 is given as a control input, that is 0 is given over here, we get all this G1, G3, G5 disabled, and G2, G4, G6 are only acting. So at the consequent clock pulse, when the clock pulse appears, this data A, B, C, D will be stored into the flip-flop, right? So shift equal to 0 means load bar equal to 1. That means this is a loading operation. Shift equal to 0 means it's a loading operation or loading will occur, right? বুঝতে পারলে কি লোডিংটা হচ্ছে?
Yes, sir.
Next, let us put shift equal to 1. So this will be 1. So this will be 0. So this one will make this one, and this one. This 0 will cause this to be 0, this to be 0, this to be 0. Since this is an AND gate, the output will be 0, 0, 0. So 2, 4, 6 will be taken out because they will be producing 0 input. And whatever value is there at this Q will be transmitted through this G1 and will be at the input of B flip-flop. So QA will be the input of B flip-flop. Similarly, QB will be transmitted because it is 1 to B, the input of C flip-flop. Similarly, QC will be transmitted and it will be input of D flip-flop, right? So under this condition, what will happen? Whenever a clock appears, this data A will come over here. This QA will be loaded to QB. This QB data will be stored in QC, and this QC data will be stored in QD. So a shift operation will occur. In the next clock pulse, another A data, if it is there, it will come over here. This will come over here. This will come over here. This will come over here. So at the end of 4 such clock pulses, the entire word, this A, B, C, D, will be passing out through this D flip-flop in a sequence QD, QC, QB, QA. So we're loading the flip-flop simultaneously when shift equal to 0 or load bar equal to 1. And when shift equal to 1, load bar equal to 0, then at consequent clock pulses, the data will be shifting towards right. And finally, the data will be extracted through the only output port QD in a serial manner. Right? Parallel in, serial out register. দেখো ঠিক আছে? Understood?
Yes, sir.
Okay. So next we'll move on to the last and final combination, that is your parallel in, parallel out. given example is given. Okay. So this will be the most simple form of register where we'll have clock pulses common to each of the four flip-flops. We'll have individual inputs to the four flip-flops and individual output to the four flip-flops from the four flip-flops. So the first clock pulse, as soon as it appears, the value present at A, B, C, D will be stored in the flip-flop A, B, C, D, or QA, QB, QC, QD will be updated at each consequent clock pulses, and this updation will take place simultaneously, that is in parallel mode, and you can read the data at any point after this clock pulse has appeared. So it's simultaneously loading the data and you can read the data simultaneously. So it will be the fastest of the registers that we have considered. But only problem is that you can only store the data and read the data. You cannot have any shift operation over here. Okay, so this is only for storing purpose. A common 8-bit parallel register IC numbers are given. You can, if you are interested, you can search for them and study. Now, I will conclude today's lecture with the concept of universal register. What is the universal registers? We have seen so far that a shift register can move either in left to right format or in right to left format. So these are called unidirectional shift register. If the registers are capable of transferring data in both left to right and right to left, then it will be called a bidirectional shift registers, because it allows the data to be shifted in left to right format or right to left format. Furthermore, if it has the capability of parallel input and parallel output transfer, along with shift left and shift right operation, that is shift serial input and serial output operation, then we call it a universal shift register. So what will be the features of a universal shift register then? It allows the data to transferred or shifted in both left and right direction. That is, it has a shift right control to enable shift right operation along with serial input and output lines associated with the shift right. It has a shift left control to enable shift left operation along with serial input and output lines. A parallel load control to enable parallel transfer of data in and n parallel output lines. That is, the n parallel output lines are there from which you can extract the n data simultaneously. And obviously, there is a clear control to clear the register or to reset the registers asynchronously to 0. And finally, there will be a clock for synchronism to synchronize all the operations. Okay. And there will be another final state that will be called a latching state, where the information stored in the register will remain unchanged. That is, it will be latched to that particular value. Okay. So when a particular register is capable of providing all these operations, that is shift left with serial input and serial output, shift right with serial input and serial output, parallel load, parallel read or parallel out. Then along with the capability of storing data, then we call that a universal register. Okay, or universal shift register. I would rather call it universal register. Now let us see the configuration of a universal register. My only comment will be, don't judge this book by its cover. It may seem very complicated, but it's very, very easy to apprehend. I'll just give you 2 minutes to go through the figure. Okay, you just go through the figure. I'll give you 2 minutes. So what is the first impression? Is it very complicated, the universal register? Right? Just look at the input lines, the output lines. There is parallel input, parallel outputs are there. There is serial input for shift right and serial input for shift left. And there are two other signals, S1 and S0. That is also present there. This S1 and S0, which are common to all the four multiplexers, 4x1 multiplexers. There is 4 input, 1 output multiplexer. So this S1, S0 will be some control logic. Okay, or it will control the mode of the register, whether it's in shift left, shift right, parallel in, parallel out, whatever. So that mode will be determined by the combination of S1 and S0. Okay, and there may be how many combinations of S1 and S0? Zero zero. What is that binary word?
4.
0, right? 0 1. The binary word will be 1. Is it visible, this particular side? Red.
Yes, sir.
Yes, sir. 1 0 2 1 1 3. See, for 0 0 operation, its binary equivalent is 0. 0 1 is 1. 1 0 is 2. 1 1 is 3. In this multiplexer, there's clearly 3 2 1 0 marked in all the multiplexers. So the first intuition says that whenever you choose this combination, right, then only these channels of the multiplexer will be enabled. That is, this channel will be passed through. All other channels will be blocked. So if you choose a control word S0 S1 or S1 S0 S00, then this channel will be passed through. That is, whatever input is coming through this channel 0 will be the output of this multiplexer. Let us see what are these inputs. Let us see by red only. So from 0 0, this input is coming from where? The output of flip flop A1, D flip flop A1, and where it is going from the multiplexer to the input of the D flip flop. So basically, the output of a D flip flop is fed back to its own input. So what will happen? At consequent clock pulses, the data that is stored in that particular D flip flop will remain unchanged. Right? If it is 0, so 0 will be at input. The next clock pulse, it will remain 0. If it is 1, if it's set at 1, so at the next clock pulse, it will see the input is 1 because that is being fed back, and it will remain there. So this condition is called no change, or say you can say latch. See that for all other cases? Right? Same output of the particular flip flop is being fed back to its input. So it's a latch condition, right? So in this case also. Similarly in this case. So there is no change, or the data, whatever is stored in this flip flop will remain unchanged, right? So for 0 0, we get a no change operation. বুঝতে পারলে? কোনো ডাউট? কানেকশনটা দেখো কি আছে, 0 তে কোনটা লাগিয়েছি, that corresponding flip flops output is get back to that particular input of the multiplexer. When 0 channel is activated, that output will be fed back to the input of that flip flop, right? Next, let us consider this 0 1 word. That is one. So this one channel will be activated. See, this serial input for shift right is one. So this, whenever the clock pulse appears, this will be transmitted to the flip flop A4. And the output of the flip flop A4, where is it going? It is going to this multiplexer. Since the word is now 0, 1, so this multiplexer will allow only this signal. So this output of A4 will be connecting to the input of A3. Similarly, the output of A3 will go to the channel 1 of this multiplexer, and in turn it is allowed to go as input to the A2. Similarly, the output of A2 will go to the channel 1 of this multiplexer, and it will be allowed to act as input to A1. So what is this operation actually happening? From A4 to A3 to A2 to A1. So you can write this as right? Agreed? দেখো ঠিক আছে, শিফট রাইট হচ্ছে তো। নেক্সট ক্লক পাসে কি হবে? A4 টা A3 তে চলে যাবে, A3 টা A2 টা A2 তে, A2 থেকে A1, A1 থেকে তুমি কি পেয়ে যাবে? আউটপুট, সিরিয়াল আউটপুট, শিফট রাইট অপারেশন। নেক্সট ওয়ার্ড দেখছি আমরা এবার তাহলে। তাই বুঝতে পারছো তো? হ্যাঁ কি না কিছুটা বলো, আমি বলতে পারছি না। সৌভিক
Yes, sir.
বুঝতে পেরেছো?
হ্যাঁ স্যার।
ওকে, সে বলতে হবে সেটা, আমি একে চেঁচিয়ে যাবো তাহলে? তোমায় দেখতেও পাচ্ছি না, গলাও শুনতে পাচ্ছি না, আদৌ তোমরা আছো কি চলে গেছো চালিয়ে রেখে বুঝতে পারছি না। আছো তো সবাই?
হ্যাঁ স্যার।
হ্যাঁ স্যার।
আচ্ছা আছো ধরে নিচ্ছি।
হ্যাঁ স্যার,
কোরাসে,
আছি।
কোরাসে আছি বলতে হবে না। হ্যাঁ আছো, ঠিক আছে ঠিক আছে। হ্যাঁ কোরাসে আছি বলে আর দেখতে হবে না, আমার কানটা যাবে। এনিওয়ে, সো নেক্সট ওয়ার্ড 1 0, the binary word 1 0, so it will be 2. So channel 2 for each flip flop will be now selected. The input at channel 2 will be transmitted at the output of the multiplexer. So for channel 2 of A1 is nothing but serial input for shift left. So this is transmitted over here, right? Then what about the output of A1? It is coming to the channel 2 of this multiplexer. So this is again allowed to be the input of A1, A2. So output of A1 will be shifted to A2. Similarly, output of A2, see, it is coming to channel 2 of this multiplexer, which allows this signal to be the input of A3. So data of A2 will be shifted to A3. Similarly, output of A3 comes to the channel 2 of this multiplexer, which is allowed to be the input of A4. So A3 data will be coming over here, right? And finally, from A4, you will get the serial output. So what is this operation? Sorry. The shift left operation. See, the data is shifting from right to left. Okay, for the control word 1 0. বুঝতে পারলে?
হ্যাঁ স্যার। Yes, sir.
Very good. Okay, thank you. Thank you. Last control word that we have is, একটা color change করি, 1 1. That's channel 3. All these channel 3s will be selected for each of the multiplexer. So at channel 3, what are inputs? These are the parallel inputs. So As soon as they are selected and the clock pulse appears, these inputs will be transferred. So the inputs of this flip-flops A1, A2, A3, A4, they will be loaded. Q1, Q4, Q3, Q1 will be loaded simultaneously in parallel manner, and the data will be available at this terminal in a parallel manner. So this will be parallel load. So this constitutes the parallel load operation. So by just changing the combination S1 and S0, you're going to achieve no change in latch. This is stored the data. Whatever we put coming, it will change. Then shift right operation, shift left operation, and parallel loading operation. This is how a universal load can be designed. 4-bit universal register can be designed using 4 masks. ওকে, বুঝতে পারলে সবাই? এবার যে তোমাদের যে হিন্টটা দেবো সেটা তোমাদের ছবিটা আঁকার সময় কি করবে? ছবিটা আঁকার সময় না টেবিলটা পরে লিখে নেবে মনে রাখার জন্য। লিখে নিয়ে মাল্টিপ্লেক্সার আঁকলে ইনপুট দিলে এবার 0-0টা করবে করে 0-0-0-0, তাহলে তোমার মাথায় আছে 0-0তে কি হয়, নো চেঞ্জ, তাহলে তুমি ল্যাচ গুলো করে দেবে। ঠিক আছে, এটা আউটপুটটা ওখানেই ফিরে যাচ্ছে, এটা আউটপুটটা ওখানেই ফিরে যাচ্ছে 0, ল্যাচটা করে দিলে। তাহলে 0-1টা লেখো। 0-1 কি হয়, শিফট রাইট, তাহলে কি হবে, A4 এর আউটপুটটা যাবে A3 এর ইনপুটে, তাহলে ওটা চলে যাবে সেকেন্ড মাল্টিপ্লেক্সারের 1 নম্বর ইনপুটে। A3 আউটপুটটা চলে যাবে থার্ড মাল্টিপ্লেক্সারের 1 নম্বর ইনপুটে। A2টা চলে যাবে ফোর্থ মাল্টিপ্লেক্সারের 1 নম্বর ইনপুটে। হয়ে গেল আঁকা। তারপর 1-0 উল্টো করো, A1 এরটা A2, A2টা A3, A3টা A4, তারপরে 1-1, 1-1টা খুব সোজা, ডাইরেক্ট ইনপুট 4টে, I4, I3, I2, I1। ঠিক আছে, ফলে জিনিসটা যতটা কমপ্লিকেটেড লেগেছিল, তুমি যদি স্টেপ বাই স্টেপ ভাঙো তাহলে কিন্তু জিনিসটা খুবই সোজা। আর যেটা বললাম না, এখানে দেখো ক্লকটা সব জায়গায় কমন আছে, স্বাভাবিক, আর একটা রিসেট অপশনও দেওয়া আছে। ঠিক আছে, so this is your universal register, and this concludes our lecture on registers. The next class we shall consider counters. কারো কোনো ডাউট আছে ক্লাস নিয়ে?
স্যার ফ্লিপ ফ্লপে ক্লক যদি না থাকে তাহলে
বলো।
মানে ফ্লিপ ফ্লপ ক্লক ছাড়া হতে পারে? হ্যালো,
না, ক্লক পাস
হ্যালো।
না দিলে ফ্লিপ ফ্লপ তো অ্যাক্টিভিটি হবে না, তাই না? তুমি
হ্যাঁ,
ক্লক না
তো
দিলে
স্যার আপনার ওই
obviously
ফার্স্ট
পাওয়া যায় there are
নোটটাতে
flip flops which are asynchronous. জোরে বলো।
স্যার তাহলে ওই এসআর ল্যাচ আর এসআর ফ্লিপ ফ্লপের মধ্যে কি পার্থক্য আছে?
এসআর ল্যাচ মানে যখন এসআর ল্যাচ বলছো সেখানে ডেটাটা তুমি স্টোর করে রাখছো,
হ্যাঁ,
ডেটাটা তুমি একবার স্টোর করলে সেই ডেটাটাকে কোনো কিছু চেঞ্জ করতে পারবে না। আর এসআর ফ্লিপ ফ্লপ মানে অ্যাট ইন্ডিভিজুয়াল ক্লক পালসেস ও দেখবে ইনপুটে কি ডেটা আছে, সেই অনুযায়ী ও স্টেটটাকে চেঞ্জ করবে, সেট রিসেট চেঞ্জ করবে।
ওই স্যার ফার্স্ট
ল্যাচে কিন্তু
নোটটাতে
একবার তুমি
এরকম
ডেটা দিয়ে
লেখা
দিলে
ছিল
কোনো ক্লকেরও
অ্যাকচুয়ালি।
ব্যাপার নেই, ও স্টোর করে থাকবে। বলো।
ওই আপনার ওই ফার্স্ট নোটটাতে ওই প্রথমে ওই সবগুলো এসআর ল্যাচ গুলোর এসআর ফ্লিপ ফ্লপ লেখা ছিল, তারপরে লেখা আছে যে মানে আবার ফ্লিপ ফ্লপের
হ্যাঁ, বেসিক্যালি
সেকশনটাতে
দেখো,
লেখা আছে যে ক্লক এসআর ফ্লিপ ফ্লপ।
হ্যাঁ 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 হ্যাঁ, ঠিক। দেখো অ্যাসিনক্রোনাস হয় যদি কোনো ক্লক না থাকে, তাহলে তুমি ইনপুট দেবে, সঙ্গে সঙ্গে তুমি এক্সপেক্ট করবে আউটপুটটা চেঞ্জ করে যাচ্ছে। যদি ফ্লিপ ফ্লপ হয়, আর ল্যাচের ফান্ডাটা কি, ল্যাচে কিন্তু কোনো ইনপুটই থাকে না, ইনপুটের অপশনই থাকে না। ল্যাচে কি থাকে, জাস্ট তোমার বলে দিচ্ছি, দাঁড়াও, এটা হচ্ছে প্রথমে ছিল ফার্স্ট নোটে তো,
ইয়েস স্যার।
হ্যাঁ এইটা দেখো, এটা একটা ল্যাচ করা ছিল।
হ্যাঁ,
এখানে দেখো ল্যাচ বলতে
পরে
যেটা বোঝাই, ডেটা এন্ট্রি কোনো অপশনই নেই। হ্যাঁ, ঠিক আছে। আচ্ছা, এরপরে এটা আছে বলছো স্যার,
হুম,
এটা এসআর ফ্লিপ ফ্লপ,
হ্যাঁ স্যার
আর
এখানে তো
এরপরে
ক্লক
ছিল
নেই,
ক্লক
মানে
এসআর
ক্লক
ফ্লিপ ফ্লপ,
ছাড়াই।
তাই তো?
হ্যাঁ হ্যাঁ
হ্যাঁ, ওটা অ্যাসিনক্রোনাস, তুমি ইনপুট দেবে, সঙ্গে সঙ্গে আউটপুটটা চেঞ্জ করবে, যে মুহূর্তে ইনপুট চেঞ্জ হবে আউটপুটটা সেই মুহূর্তে চেঞ্জ করবে। কিন্তু এখানে তা না, এখানে ইনপুট দিলে আউটপুট চেঞ্জ করবে না, এখানে ইনপুট দিতে হবে এবং ক্লক যদি হাই হয় তাহলে আউটপুটটা চেঞ্জ করবে। কেন? অ্যান্ড গেট আছে। যদি ক্লকটা জিরো থাকে তাহলে এই আউটপুটটা সবসময় জিরো, এর আউটপুটটা সবসময় জিরো। আর এস ইকুয়াল টু জিরো আর ইকুয়াল টু জিরো মানে এটা ফিক্সড, কোনো চেঞ্জ হবে না। যদি ক্লকটা ওয়ান হয় তখনই এস আর আর এর ভ্যালুটা অ্যান্ড গেটের থ্রু দিয়ে পাস করবে, মানে এটা 1 0 0 1 এসব হতে পারে, তখন এই ভ্যালুগুলো চেঞ্জ করতে শুরু করবে। ক্লক যদি ওয়ান থাকে আর ক্লক জিরো হলে সব জিরো জিরো, এস ইকুয়াল টু জিরো আর ইকুয়াল টু জিরো মানে ওটা তখন কোনো ভ্যালু চেঞ্জই করবে না, ল্যাচ হয়ে পড়ে থাকবে। হয়ে গেল?
স্যার যেটা ক্লক নয় ওটা একটু বলতে
রাহুল,
পারবেন তো?
হ্যাঁ স্যার, ওই
এটা ক্লক
বলছি
নয়,
যেটাতে ক্লক নেই সেটা একটু বলুন। হ্যাঁ,
এটা তো কোনো ক্লক নেই, তুমি যে কোনো ইনস্ট্যান্টে
এটাতে
যদি আর ইকুয়াল টু জিরো আর এস ইকুয়াল টু জিরো দাও, কোনো চেঞ্জ হবে না, ঠিক আছে? আর ইকুয়াল টু ওয়ান, এস ইকুয়াল টু জিরো দিলে সমস্যা কি হবে? এটা 0 1 হয়ে যাবে। এস ইকুয়াল টু ওয়ান আর ইকুয়াল টু জিরো দিলে কি হবে? এটা 1 0 হয়ে যাবে। যেই মুহূর্তে তুমি ইনপুট আউটপুট চেঞ্জ করবে সেই মুহূর্তে আউটপুটটা চেঞ্জ হয়ে যাবে। সামান্যটাই ডিলে থাকবে, ন্যান্ড গেটে এই নর গেটে যতটুকু ডিলে সঙ্গে সঙ্গে চেঞ্জ হবে, কোনো কিছু ক্লকের জন্য ওয়েট করবে না, একদম ইনস্ট্যান্টেনিয়াসলি।
হ্যাঁ সেটা
তোমার যদি
ঠিক আছে স্যার, তাহলে এটা তো
8টা,
নর বেস্ট, এটা নর বেস্ট এসআর ফ্লিপ ফ্লপ, তাহলে নর বেস্ট এসআর ল্যাচটা কেমন হবে?
এটা ল্যাচও বলতে পারো, ল্যাচ মানে নরবেস এসআর ল্যাচ তুমি বলতে পারো না। তুমি যদি এটাকে জিরো তখনই ওটা ল্যাচের মধ্যে কাজ করবে, তাহলে ভ্যালুটাকে স্টোর করে রাখবে। তুমি যদি কোনোভাবে এখানে ইনপুট দাও তখন কিন্তু ওটা চেঞ্জ হয়ে যাবে। যদি তুমি নরবেস এসআর ল্যাচ বলো, আর তুমি যদি সিম্পল ল্যাচ বলো যেখানে কোনো ডেটা দেওয়ারই অপশন নেই, জাস্ট রম, রিড অনলি মেমোরি যেগুলো থাকে সেগুলো তুমি ডেটা ম্যানিপুলেট করতে পারো না। যা একবার দেওয়া আছে সিডিতে, যেমন যা একবার দেওয়া আছে তাই আছে, নন রিডারেবল সিডি। এখানে দেখো তুমি যদি কিউ ইকুয়াল টু জিরো এটাকে একটু ওয়ান দিয়ে রাখো, ওখানেও ভ্যালুটা পড়ে থাকবে, কোনোভাবে কোনো চেঞ্জ হবে না। আর যদি এসআর ল্যাচ করতে হয় তাহলে তোমার কি করতে হবে, এটা তো বুঝতে পারছো, কিউ ইকুয়াল টু জিরো, কিউ এটা ওয়ান, ওটা সব সময় থাকবে, তোমার কোনো ইনপুট দেওয়ার জায়গায় নেই। এটা হচ্ছে একটা ল্যাচ, মানে এটা সিম্পল মেমোরি এলিমেন্ট। তুমি যেটা বলছো এসআর ল্যাচ, যদি তুমি এখানে এনশিওর করতে পারো যে আর ইকুয়াল টু জিরো, এস ইকুয়াল টু জিরো, তাহলে এই ভ্যালুটা যা আছে সেটা দিয়ে ল্যাচ করে থাকবে, কোনো চেঞ্জ হবে না। এটাকে তখন আমরা বলবো নো চেঞ্জ বা ল্যাচ কন্ডিশন, এসআর ল্যাচ। কিংবা এটাতে অ্যাসিনক্রোনাস সার্কিট, এখানে কোনো ক্লক নেই। এই যদি ক্লক থাকে তাহলে একই ব্যাপার, তুমি এটাকে 0 0 করে দাও। এটাতে ক্লক নেই, ধরো ক্লক আছে, আমরা সিচুয়েশন দেখি, তুমি এটাকে 0 0 করে দাও না, এখানে জিরো ইনপুট দাও, এখানে জিরো ইনপুট দাও, ক্লক জিরো থাক আর ওয়ান থাক, যা আছে কিউ, কিউ আর সেম থেকে যাবে, মানে ল্যাচ করে থাকবে। তাহলে এনশিওর করতে হবে এস ইকুয়াল টু জিরো আর ইকুয়াল টু জিরো, এস ইকুয়াল টু ওয়ান আর ইকুয়াল টু জিরো হলে সেট, এস ইকুয়াল টু জিরো আর ইকুয়াল টু ওয়ান হলে রিসেট, প্রোভাইডেড ক্লক ইজ ওয়ান। স্টেট তখনই চেঞ্জ করবে যখন ক্লকটা হাই থাকবে, ওয়ান হবে। সুতরাং অপারেশন ইজ ডিটারমাইন্ড বাই দ্য স্টেট অফ দ্য ক্লক। আর ক্লকের তো কি হয়, ক্লকটা কি, ক্লকটা আমরা কি, এটা হচ্ছে ক্লক, লো হাই, তাই না? সুতরাং এই সিচুয়েশন গুলো খালি এস আর আর এর ভ্যালুটা রিড করবে, সেই অনুযায়ী কিউ আর কিউ ড্যাশটা আপডেট করবে। এই বাকি সময়, এই সময় কিন্তু কোনো চেঞ্জ হবে না। এটা হচ্ছে ক্লক টেসার ফ্লিপ ফ্লপ বা ক্লক টেসার ল্যাচ, তুমি যাই বলো। ঠিক আছে?
ওকে স্যার।
আর কারো কোনো প্রশ্ন আছে? আচ্ছা, তোমার হ্যাঁ বলো বলো।
স্যার বলছি আগের দিনে যে ফ্লিপ ফ্লপে যে কনভার্সন গুলো দিয়েছিলেন, তো ওখানে তো ভুল কিছু পাইনি, মানে আপনি
হুম,
বলেছিলেন ভুল আছে ওখানে।
তাই?
মানে
কার্নো ম্যাপে কোনো ভুল ছিল না?
না মানে যেগুলো করলাম সেগুলো তো মানে আসেনি কিছু।
তোমরা কেউ ভুল পেয়েছো কোনো কার্নো ম্যাপে? ভুল না পেলে ভালো, ঠিকই আছে, প্রবলেম কি আছে? আর ভুল পেলে আরো ভালো, এটুকু বলতে পারি। ঠিক আছে, এটা মন দিয়ে করো, মন দিয়ে করো, দেখো কয়েকটা হয়তো ওয়ানের জায়গায় জিরো পড়ে গেছে। আর ওইটা তো চেঞ্জ করে নেবে। হ্যাঁ, যখন ন্যান্ড গেট দিয়ে এসআর ফ্লিপ ফ্লপটা বলা আছে, ওগুলো সব কিন্তু এস প্রাইম আর প্রাইম হবে, মানে কনজুগেট হবে। হ্যাঁ, কমপ্লিমেন্টারি সেট গুলো হবে। ওটা আমি পিডিএফটা চেঞ্জ করতে পারছি না, ডকটা পাচ্ছি না, চেঞ্জ করে দিতাম। দেখিয়ে দিই, যখন হাতের কাছে খুললাম ওটা দেখিয়ে দিই। এই লেখাটা দেখো, যখনই আমরা এটা করেছি, আচ্ছা এসএস অ্যাটাচ করা আছে, ঠিক আছে ঠিক আছে, ওকে, এটা কারেকশন করাই আছে। আমার কাছে যে ভার্সনটা ছিল সেটাতে করা ছিল না, এখানে এসএস অ্যাটাচ করা আছে। তাহলে এখানে দেখবে কিউএন দুবার করে লেখা আছে, একটা করে ইগনোর করে নেবে। ঠিক আছে, মানে একবার সাফিক্স করা আছে, আবার সাফিক্স করা নেই, ওটা খালি নিগ্লেক্ট করলেই হবে। বাকি এটা ঠিকই আছে, এটা বাকিটা ঠিক আছে। মানে এটাই তোমাদের পাঠিয়েছি নাকি গো পিডিএফ? আমার ল্যাপটপে যে পিডিএফটা আছে সেটা ডিফারেন্ট, আমি ক্লাস আসলে ল্যাবে আছি, এই পিডিএফটা দেখি ঠিকই আছে, এটা হয়তো পাঠিয়েছি তোমার। ঠিক আছে, ইটস ফাইন। তাহলে সম্বিত,
স্যার
এমন হতে
জেকে
পারে যেহেতু এটা
স্যার
দেখছি আমি কারেক্টেড, কোনো
স্যার
ভুল নাও পেতে পারো।
স্যার জেকে2 যেটা ডি যেটা আছে ওটাতে একটা ভুল ছিল খালি, মানে জেকে ফ্লিপ ফ্লপ টু ডি ফ্লিপ ফ্লপ যে কনভার্সনটা
জেকে তো
ছিল
ডিতে একটা ভুল ছিল।
একটা ভুল ছিল। আর
আচ্ছা,
মানে আমি অ্যাকচুয়ালি ট্যালি
হ্যাঁ,
করিনি পুরোটাকে সলভ করার
আর
পর। আর দাঁড়ান বলছি।
হ্যাঁ,
মানে ওখানে যেটা ফর কে যেটা আছে ওটা
বলো।
1 আর 0টা ইন্টারচেঞ্জ হয়ে গেছে।
হুম, হ্যাঁ, ওই একটাতে জায়গাতে হবে, আমি জানি একটা 0-1 চেঞ্জ আছে ইন্টারচেঞ্জে। ঠিক আছে, তুমি কোনটা বলছো, জেকে টু ডি তো?
হ্যাঁ ওইখানে ফর কে যে আমি কার্নট ম্যাপটা বানিয়েছিলাম, সেখানে ওই
এক্স্যাক্টলি 1 আর 0টা ইন্টারচেঞ্জ হয়ে গেছে।
1 আর 0টা ইন্টারচেঞ্জ আছে।
এক্স্যাক্টলি, গুড। আর আর কোনো ভুল?
আর
ডি টু এসআর দেখবে, ডি টু এসআর এ দেখবে একটা গন্ডগোল হতে পারে।
কিছু আছে?
ডি টু এসআর, হ্যাঁ, ডি টু এসআর আমি বলে দিচ্ছি। আর
0
কিউ
0
ইকুয়াল টু
হবে।
1-1, এস ইকুয়াল টু 0 এই রোতে।
হ্যাঁ স্যার ওটাতে স্যার ওই ওই ওপর
0-0 হবে ওটা।
হ্যাঁ ওটা 0 0 আসছে ওটা। ঠিক। মানে আমি
0-1
আমি
0-0 হবে ওটা।
হ্যাঁ 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 মানে আমি সলভ করেছি বাট কার্নট ম্যাপ গুলোর সঙ্গে ট্যালি করিনি, তলার ইকুয়েশন গুলো জাস্ট আমি মিলিয়ে নিয়েছিলাম, তো ওখানে সব ঠিক ছিল।
তাহলে এই দুটোই ভুল ছিল, তাই তো?
হ্যাঁ স্যার।
এক্স্যাক্টলি, বাকিরা সব জেনে নিলে এবার নিজের দায়িত্বে কারেকশন করে নাও, পরে বলবে না স্যার আপনি বলেননি। সম্বিত আছে, সম্বিতের সাথে কমিউনিকেট করে নেবে, ও তোমাদের সব কারেক্ট করে দেবে। শুধু ও কেন করবে, তোমরা নিজেরাই করতে পারবে, হিন্ট তো পেয়ে গেলে। ঠিক আছে, আর কোনো ডাউট করো? তো সম্বিত আবার নিশ্চিন্ত, ভুল পাওয়া গেছে, নিশ্চিন্ত ঘুমো আর ভালো করে প্র্যাকটিস করো এই কনভার্সন গুলো। ঠিক আছে, ঠিক আছে, আজকে তো এইটুকুই থাক। ছেলে আছে না চলে গেছে? হ্যাঁ আছো তো, ঠিক আছে।